Hey everybody, welcome to this video about atomic types in Python. Today I'll first give you a quick introduction to using a notebook, and then I'll talk about atomic types in Python, what we can use them for as we learn to program. So first of all, in the beginning of this course we'll be giving introductions to the fundamentals of Python, which includes a lot of things that are written up here. The main thing to note is that these things in the beginning will be a bit abstract compared to the rest of the course, which very much focus on what you can use Python for. The central takeaway you should take is more the language that we're using and sort of a bit of an underlying understanding of what's going on as we code and as we write our code. But it's not about memorizing all these names that I'll be talking about, or like what atomic is, and then there's a lot of types under that. Like, it's not about memorizing these things. It's the main thing when you're watching all of these videos is understanding, and then you can always go back to the notebook if you're uncertain about something. And this also goes for like all the notebooks in this course, that you sort of view them as reference sheets. So when you're working on problem sets or assignments, and you're having a problem you can't figure out, but you know, okay, we had this lecture about something that's reminiscent of it, then you can go back to that lecture and sort of find, and you can even later on, like, it's not going to be that much code in this notebook, but in some of the later notebooks there'll be a lot more code, and then you can actually copy some of it and then make it work to your specific problem. That happens a lot when you code, that you're copying similar code and then sort of rewriting it to your specific problem. Yeah, there are some extra links here if you want an even more detailed tutorial on like introduction to Python and all the different things you can do. Then there's also a link to Markdown, like all these blocks that are not code but text are written in Markdown, as you can also see down here. Otherwise I would say Python if it's code block. The Markdown language is not really that intuitive for me, at the very least, but it's really good, and once you sort of learn how it works and how you get stuff out, then it will become more intuitive. So yeah, maybe I should start here. So this is a Markdown cell, and if I press enter, then I can edit in the actual text that makes you get this output. Yeah, press enter, and then sort of, for example, if you use these stars around something, then you make it bold. This to make a link. You can also make a heading. So right now, as you can see, this is a code cell, but I can turn it into a Markdown cell. I'll show you how below. But you sort of, if you want to make a heading, then you use the hashtag at the beginning. So there's a bunch of that on this link, which is not really relevant for you now, but it will be when you're doing assignments and you're writing your own notebooks and you want to make them look at least a little bit good. Yeah. So using a notebook, hopefully, like in the best of worlds, then every one of you have downloaded the VS Code and Python and Anaconda, and you've also gone on GitHub and downloaded the notebooks. I know some of you are gonna have problems with it, and you talk with your TA about it, sort of downloading Python, like sometimes something just happens and then it doesn't work as supposed to go. If you want to maximize your chances of nothing going wrong, then you should follow the installation guide as closely as possible. And yeah, in my view, it's the ideal way to sort of go through these notebooks and these videos is to have the notebook open on your own computer as you're watching the video, and then running the code as you go along. You can also run the code afterwards, so watch the video and then run the code. I mean, that's how you prefer it, but I think it's very important that you actually run code on your own computer as soon as possible, and and as much as possible, because that's really how you learn and get it into your fingers, sort of what's going on, and exactly how it's working instead of just watching me do a lot of stuff. And as the course goes along, there might be some minor changes to the notebooks that are on GitHub. So if you have your notebooks through cloning, so you use this git clone to get the notebooks on your computer, then you can use git sync to synchronize the changes that will probably come as the course goes along. To do that, you press Control Shift P, and then you write git sync, and then you press enter. And then this little loading thing will start, and then it will disappear once it's done. And yeah, it's really important that you get Python working on your own computer. So yeah, do what you can, and sometimes there'll be issues that are really hard to fix, and then you should talk to your teaching assistant and get them to help you. They're there to help you also with this stuff, not just with the purely coding things. It's also important to know how to install Python, and they're there to help you with that. Okay, so now we're in VS Code on a notebook, writing code. Right now we're just looking at text, but you'll soon be writing code. There are a lot of shortcuts which makes it a little bit easier than just pointing and clicking and then writing. The most important, or my opinion, some of the most important are here. On the course website there are even more. So yeah, if you want to just run a cell and then move along, then you can press Shift Enter. If you want to run a cell but stay on it, then you can press Control Enter. If you want to create a new cell, then you can create A or B depending on whether you want it to be below or above. And then if you actually want to write in this cell, you should be sure that this is one cell, this is a different cell, this is a different cell. So that's what I mean by cells, if you're uncertain. Okay, so yeah, if I want to write in a cell, I can click on it. But if I don't want to click on it because I'm lazy and don't want to touch my mouse, then you can press Enter, and then you can write something. And then to get out of editor mode, you can write press Escape, and then you're out again. If because this is not code I've written, this is just random text, I can turn this into a markdown cell. I can still write in it if I press Enter, but now, as you can see, it's a markdown cell, not a code cell. I can turn it back by pressing Y, and then I can delete the cell again by double tapping D. So you'll get familiar with this as you go along, but it's good to know that there's a list of shortcuts here. So if you're at some point annoyed about using the mouse too much, then you can go through those shortcuts. Yeah, so now we're going to talk about variables. Atomic types is a form of variable, but first I want to introduce what a variable is. In Python, it's a reference to some place in memory where data resides, sort of a funky way of saying it. It's just, you should just see it as sort of, I think you should see it as the data that you're looking at as you're coding, but you should know that sort of the computer just looks at it as an address, where it's sort of, the variable is an address to some data or something. And you can get that address with a function. You're not going to do that in practice very often. There are many types of variables. The ones that store data directly, they are atomic types. In another notebook, we'll be talking about containers, which sort of store, they can store containers, but they can also just store many different atomic types, or the same atomic type, but sort of many different instances. So you can have multiple elements. It can be a data set, for example. Yeah, there are 4 types of data or atomic types, which are booleans, which is just true or false. So it can only take 2 values. Then there are integers, which can take all the values from minus infinity to infinity, but it cannot show you decimals. It can only show you like the numbers 1, 2, 3, 4, and the negative numbers. Then there are floats or floating point numbers, which are numbers with decimals. And then there are strings, which text. The text can also be numbers, but it's stored differently when it's a string, and it acts more like text. Yeah, they use different amounts of memory per unit. It's not that important for you right now. But for example, if you have something that is really numbers and you store it in a string, then optimally you would like to change it back to integer or float to not waste a lot of memory. Yeah, and as I said, a variable that references these types of data directly, that's an atomic type. And yeah, the data of an atomic type, unchangeable address, this is sort of going back to this address thing where it's references. So you can't really, if you have a variable that's 1 and you change it to 2, then it's actually a new reference, even though you call it the same thing. In practice, this doesn't change that much what you're doing. And then containers are things like lists, dictionaries, and data frames. So data sets, basically. That's from another notebook. And they can change. So if you have a list with a bunch of like numbers, then you can change some of the numbers, and it's the same reference. All variables are also called objects, and functions are also called objects or variables, and can be defined like with names, similar. Okay, so now I'll go through the atomic types. So first we have integers, like all the numbers with no decimals. And let me just show you how it works. This code cell is not really important. That's just to get the size on the computer. So if I go down, or maybe say what I'm doing. So I go into this block and then I press Control Enter, which means I run the code in it. And it's a code cell, so the Python code cell. Yeah, then what the code does, it defines an integer as 1. Python knows it's an integer just because you write in an integer. So I write 1, that's an integer. Python knows that will be an integer, so I try to print, okay, what is the type? This is a Boolean function. What's the type of this x I've created? That's an integer. I can also just print the value I have stored in the variable, which is 1. Then I can get the address with this id built-in function, and I can also get like how much memory does this variable take up, which is 28 bytes. Yeah, and if I want to make a new, so here I make a new variable or a new reference, but I still call it x, and now it's x times 2, so it's 2. Then, as you can see down here, it becomes 2, x equals to 2, but the address is something new. It's a new number. So this is what it means when we say you can't change these variables. And also, I could have written 2 down here. Then you get x equals 2 and x equals to 4. And sort of play around with that. Now we go down to floats or floating point numbers, which are decimal numbers. Yeah, and you define it like again with equal. Now just because we write 1.2, then Python will know as I run the code that this is a float. So a floating point number. Python just calls them floats. And you can see that the size is slightly smaller. But that's not really that important. You can also, like, so if you want to write 1, but you want it as a floating point number, then you just put a dot at the end, and then it's still a float, even though it's close to 1. Almost exactly. It's almost exactly 1. You'll learn about that in a later notebook. Yeah. So that's floating point numbers. Then there are strings, which is a text. Here it's defined as ABC, could be some other text. The way Python knows it's a text is because you're using these quotation marks. So if I just wrote ABC then that would throw an error. It would make Python confused basically and say this code doesn't work. But when you're using the quotation marks, then it works. And also if you write 1 here, then because you're using the quotation marks, Python knows it's a string and not integer. Let's start with ABC. So as you can see, type is string. It can print in the same way as integers and floats can, and the size is quite a lot heavier. You can also use double quotes instead of single quotes. That's when you're just writing a string like this, then it's only preference. Sometimes you can have quotes inside of quotes, but don't worry about that yet. Here it's the exact same. This should just be like this. The next type is booleans or bools, which is just true or false variables. So you just write it here with a capital starting letter, and then you just write true. Then Python knows it's a boolean variable, and typically it will also change color. And then it's the exact same. You get the type, you get the value, which outputs as true. If you want to write false, then you just write false. And you can only, like booleans can only be these two types. So that's the atomic types: integers, floating point numbers, strings, and booleans. Sort of the syntax in Python is that integers you just write int, floating point numbers you write float, strings you write str, and booleans you write bool. Those become important now if we want to look at type conversion, because you can switch the types of the values of these variables, and that can be important for these memory issues. And also sometimes, like the different types, they behave differently. So sometimes you want a different type. And the way you change the type is just using these shorthands with brackets around the number. So if we want to turn 1.2 into a string, then we just write x equals 1.2, so that's a float, and then we define the string version of x here. The print is the same, but now the type is a string, and that can be useful in some cases. When you change the type from a float to an integer, then you should know that it will always round down. So 2.9 becomes 2 and not 3, which initially might be more logical, but as long as you know this, then you sort of can get it. And there are functions to sort of round the normal way. So this is just turning the floating point number x 2.9 into an integer, as you can see with this print statement. There's one thing you cannot do, which is also logically, you can't write up a string with letters in it and then turn it into an integer, because Python doesn't know what that integer would be. So this block of code sort of, it says I'll try to do these lines of code, but if I can't do them, then I'll just print this, and it just prints that cannot be done. And the indentation for these things where you try to do something is Python does them automatically when you wrote the semicolon or the colon, but you can also just create it with tabs or 4 spaces depending on your preference. But you can convert strings that only has numbers into an integer or a float. So if you take this string 22.2, you can turn it into a float. This string of 222, you can also turn into an integer. You could also turn it into a float, like this. But you cannot turn 22.2 directly into an integer, which is sort of the way you would do this if you really wanted to do it, would be to first turn it into a float and then turn it into an integer. Python just doesn't accept like directly transferring the string of 22.2 into the integer of 22. And now I have a little question, which you can try to answer at home. Do you think you can convert a Boolean variables that is equal to false into an integer? And then there are a couple of possible answers. You can pause the video and try to think about this. And it's very allowed and even encouraged to just try it using your code to get the answer out. But yeah, pause the video now and then see if you can get the answer. Okay, hopefully you got the answer right. Otherwise, I'll just show you how you would find the answer. You can just test it out. So you say x is false, and then you create y, which is the integer version of x, and then you can print y. And then what we're gonna get out is 0. If x was true, then we get 1 out. So that's sort of the computer way of understanding true and false. It's just 0s and 1s. Yeah. Now we go down to operators, which is sort of if you want to do something with the variables you have, then you use operators. So you're doing an operation on them, basically. A lot of the operators are normal in the sense that we know them, like plus, minus, division, multiplication is the star. If you want to take something to the power of something, then you use 2 stars. A lot of you, I know I did this, would sort of just like out of habit write this, which will throw an error, because that's not the way Python views exponentation, taking something to the power of something. But you'll get used to it once you do it a couple times. Just try to remember it. Double stars is taking something to the power of. It's not multiplying, it's taking the power. Yeah, and then here I just print out the outputs. It's sort of what you would expect. You have 3 and 2, and then 3 plus 2 is 5. 3 minus 2 is 1. Division, blah blah. All this is sort of what you would expect to get out of it. And here you have x to the power of 2, so it's 3 to the power of 2 is 9. You can use some of the same operators on other types. So here we're using integer types. It works the exact same for float types. Now it's just unintelligible numbers. For strings, it's a bit different. So if you have these 2 strings, ABC and DEF, and you add them together, then you get ABCDEF. So it sort of concatenate them together. You can also multiply a string by an integer. So if you take ABC and multiply it by 2, then you get ABC, ABC. And if you multiply by 3, then you get ABC 3 times. Yeah. And then we have another question. Again, you're very encouraged to just write the code on the computer to get the answer. But maybe think about what would you expect to get if you have 3 and then double stars and 2. What is the output here? Yeah, I realize now I didn't ask you to pause. So just show you the answer real quickly, and you get 9 out, because it's 3 to the power of 2 with the double stars. And then you should also note then whenever you divide like integers from each other, then Python will create it as a floating point number, even if you have something like 8 divided by 2, you'll still get a float out of it. It will just be a floating point number 4.0. If you want to make sure you get an integer out, or if you want to get an integer out, then you have to write 2 underbars or slashes. And then you will get an integer out, but it will round down. So if you had something like 10 divided by 3, then it just puts out 3, even though the real answer is 3.3, as you can see here. You should know that. Just remember that if you really want integers out, but you don't want to lose data, then you should ensure that your division is actually creating an integer. Then you have argumentation operators. These, like, the reason you have these is basically just to write less amount of code. So what they do is you have a variable which already has a value, and you want to do something where you add something to that value, or you subtract, or you divide. So if you write x equals to 3, and then you write x plus equal 1, that's the same as writing x equals x plus 1. So you're basically doing an operation on x and returning the output with the name x. So here you start out with having 3, then you plus 1, then you get 4, then you multiply it by 2, so you get to 8, and then you divide by 2, so you get to 4. And here we see that because we're doing division, then it turns out as a floating number, even though 4 is actually could be stored as an integer. Then you have logical operators, which returns, or you can also call them Boolean operators, but what they return is a Boolean value. So this is logical operators basically returns whether some condition is true or not. So you have whether something is equal to something, whether it is not equal. So this exclamation mark is not equal. Then you have less than or equal, larger or equal. And then you can see the output here is these Boolean variables, false, false, true, false. You can sort of go through those. You have x is 3, and y is 2. So is x smaller than y? No, 2 is larger than 3. And then it prints out false. And then this is just whether x is smaller than. If you assign something with this operator, then it will also be assigned as a Boolean variable. Normally, that is not important. Normally you would also write like this, just be sort of explicit that this is a new variable. But it's not important for now. That's the end of this video. The central concepts in this video are variables, and that they're actually a reference to somewhere in memory, and you can also call them objects. Then the main important part of this video is the different types you've been introduced to, what values you can put into them, the operators you can use on them. Argumentation is also nice to know what it is, because a lot of people use it, and it can be nice to use. It's a bit easier to write and a bit easier to read once you get the hang of it. And then these comparison variables or comparison operators, which returns Boolean variables. Thank you for watching this video.